Hello everyone. In this lesson, I would like to go over the basic definition of logarithms. Logarithm of some positive number n is the exponent to which the base b must be raised to obtain n. So if n is equal to the base b raised to the exponent of x, given n greater than 0, b also has to be greater than 0. And don't forget that I don't have an equal to 0 here. Alright, so they have to be a positive number and they cannot be equal to 0. And b also cannot be equal to 1. Then I can write x as logarithm of the base b of certain argument n. Alright, so I can say n equal to the base b raised to the exponent of x is the exponential function, or I can call that is the exponential equation. And you have to solve for x in this case. Alright, so x is the unknown, but x is the exponent. So how do we solve for that? In order for us to solve for x, we have to apply the operation of logarithm. So you write x equal to logarithm of the base b of n to solve for x. So basically, I can say that logarithm is the inverse operation of the exponent. But what kind of base that we are talking in this case? Okay, so in this class, we will go over the base 10 and the base e. And what is that number e? The number e is the irrational number 2.71A2A1A2A1 repeating. In order for us to get this number e is the complicated concept of involving many steps in calculus, which we will not cover in this class. But this number e is so important in calculating many important concepts in engineering, especially when you connect a circuit with an inductor and a capacitor, as we have learned in previous lesson. Alright, so to simplify the concept of solving for x as the exponential equation in this case, alright, and then we have to use log to figure out x. Let's take a look at our calculator. The calculator will simplify all that process for us. Okay, so in this class we are using the calculator Casio FX991MS. I would like everyone to pay attention to these two keys on your calculator. The key called log, L-O-G, and the key beside that called Ln. So let's talk about one at a time. So log, so that's the key that I would like everyone to pay attention to. So I can write log of the base 10 of certain argument. Okay, so in this case I don't know what that argument is. It's equivalent to writing log of that argument n. So notice that this is the base 10 and I can write the 10 right here. Alright, so I don't have to write that 10. If I don't write that 10, then I must understand that this is log of the base 10. So if you have any base other than 10, let's say you have base 2, base 3, base 7, then you have to indicate that. You have to write it, log of the base 2, log of the base 5. But if you don't write anything here, then it's called common logarithm. So if we mention common logarithm, that means we are talking about log of the base 10, and we don't have to write that base 10 beside this letter G in this case. Alright, okay. So if you can take a look at this note right here, if I have log of 5 is equal to log of the base 10 of 5. And this is common logarithm, or I can call common logarithm of 5. So that's how we say it in sentences. Okay, so keep that in mind. If I ever mention common logarithm it means that I'm talking about log of the base 10. So now, take a look at another key beside. So the key beside this, it will be the ln, alright? So the ln, okay, of certain argument in this case. Okay, so it means it's equivalent to the log of the base e of this certain argument. Okay, so e is the irrational number 2.7182A1A2A1. Then ln representing log of that base e. But this log of the base e has a special name. It's called natural logarithm. Okay, so natural logarithm of certain argument, then we have to understand that it's a log of the base e. And we don't usually write log of the base e in this case. We have to indicate that it's ln or ln of an argument. So take a look at this note. I wrote it here, ln of 5 means that log of the base e of 5. Alright, and we don't usually write log of the base e, but we have to write ln of 5. Okay, the same for this calculator here. It's at ln and it's at log. So the difference between the two is called the common logarithm is the base 10. The natural logarithm ln is the log of the base e. So keep that in mind, and we will work with quite a few examples involving these two keys on your calculator. Okay, before we move on to the next page, I would like everyone to pay attention to this these formulas right here. Okay, so if I have log of the base b of an argument, and my argument happen to be an exponent, okay, so if an exponent, then it means I have a base and the exponent x. Okay, so you see the base of this power is the same as the base of this log, so I can conclude that this is equal to x. And the next one I would like everyone to pay attention to is the ln. Okay, so the ln e to the x is equal to x is because I can write this as log of the base e of e x. So you see these two bases are the same, so I can conclude that this is equal to x. This is one of the special formulas in calculating operation involving logarithm and natural logarithm. So let's move on to the next page. Okay, and next page I will talk about the key above the natural logarithm key and the common logarithm key. And I would like you to note that above these two keys, you will see that there's a 10 to the exponent x, and the other one is the e to the exponent x. Okay, so you see that this is a natural logarithm, so it's the base 10. So the inverse operation, that would be 10 raised to the exponent x. And here's your natural logarithm. It means you have the base of this log is equal to e. So the opposite operation with that would be take e raised to the exponent x. So let's talk about the inverse between these two on the next page. Alright, okay. So let's continue here. We are going to use our calculator intensively. So if you can get that calculator and then put it right beside you and start working with me in this example. Okay, so excuse me. As you know, whenever I pause, I would like to take a sip of my tea. And if you hear the noise outside, like this is when we are working from home and we can avoid those noises outside the window. But hopefully you don't hear those noise at all. But I hear it here while I'm recording this lesson for everyone. Alright, so I hope that everyone get a calculator in front of you. and we are going to key in certain number in this calculator. Okay, so first of all, take a look at this. Okay, so I would like to draw everyone attention to example number 1. Okay, example number 1, I say log of 10 equal to 1, and I say common logarithm of 10. So it means that when I say common logarithm of 10, it means we have to understand it's a log of the base 10. Okay, so why don't we do that? You key into your calculator log and you put 10, then you put equal sign, it should be equal to 1. And then the same thing here. So let's get our calculator out. Okay, so I have a image of the calculator. So I'm going to ask everyone to key this in. Alright, so you press this key. Okay, so press that key. Then you should see there's a log up here. So that will be log. And you key beside that number 10. Okay, so you put in 10 like this. And then you press your equal sign. Equal sign. Immediately you see that it's equal to 1. Alright, okay. So in this case that you are finding natural logarithm of 10. Okay, then below that I kind of give some proof for everyone. So let's get back to our handouts. So this one. Okay, beside this, did you see that I put natural logarithm of 10, which that means the base 10 for log, and this also have the 10 is equal to 1. So do you see that 10 raised to exponent 1 is equal to 10? So in the way I want to prove this formula up here for everyone, I want to show you that this formula works all the time. Alright? So if you want to convert between exponential equation and logarithmic equation, then it's proven each time if we do it correctly. Alright, okay. So now go to the next example here, which is the common logarithm of 1000. When I say common logarithm of 1000, it means that we are going to have log of the base 10 of 1000, and in this case is equal to 3. We will use our calculator to prove that in a minute, okay? So if you take a look at this function right here, okay, I will write 3, in this case is x, okay? So the base is always equal to 10. So I got 10 raised to exponent 3 is equal to 1000, which is true. And always true, right? So you know that 10 raised to exponent 3 is equal to 1000. In terms of logarithm, that means I have to convert this base 10 into the base of my log, and the argument become 1000. And common logarithm of 1000 will be equal to my exponent, which is equal to 3. So you see it's proven that one formula is the opposite operation of the other. Okay, why do I keep saying opposite operation? Because you will see that happen in our next lesson, which is the application for the DC RLC circuit. So let's get back to our calculator. Okay, so our calculator. Now I would like everyone to key in not natural, but common logarithm of 1000. Okay, so when I say common logarithm of 1000, it means I'm talking about this key. So you press that key, so you will have log. The word log will appear on your calculator, and you will key in 1000 beside it. Right? So 1000 is your argument for this log, and you press your equal sign. You should get the answer as 3, which is very true, right? So we have 10 raised to exponent 3 equal to 1000 in this case. Okay, so the corresponding exponential function with a logarithm would be log So the same base applies. So this base for the power is 10. So it's also the same base for this log, which is 10. And the argument now is a number on the other side, which is 1000. Is equal to 3. Okay, so you see that if this 3 here is some unknown that you have to find, then you have to apply this logarithm to find that unknown. Alright, okay, so what about natural logarithm? Okay, so let's get back to our calculator. I mean this slide right here. Now we are talking about natural logarithm, and it means that if I have n and I raise n equal to e to the exponent x, then x will be equal to natural logarithm of n. So the most important part here is to learn how to key this into your calculator, right? Where you are having the base, okay, as e, but you don't have to worry about the base e because it's representing by the ln key on your calculator. So all you have to worry now is to how to put in the argument as e. Okay, right? So the argument as e. I will show everyone how to do that in a minute. Okay, so let's talk about the relationship between this part here. So if I have the log of the base e of the argument e is equal to 1, the same things as I write natural logarithm of argument e equal to 1. And now you taking this base e, you raise to the exponent 1, so it's the exact same thing again as e. So if you take e, you raise to exponent 2, it had to be equal to e to exponent 2. The presentation in terms of logarithm would be natural logarithm of e of exponent 2 will be equal to 2. So let's try that using our calculator, okay, because it's very easy to make an error in this case regarding the Casio FX991MS, how we key in the e into this calculator. Okay, so I'm sorry everyone, it's quite noisy outside because I think there's construction outside my home right now. But I hope it won't interfere with the recording because I hear it, but I'm not sure if it actually recorded. Anyway, so get back to our calculator. Now we are going to work with our natural logarithm key. Okay, so natural logarithm and an argument is equivalent to the log of the base e of this argument. Okay, so in previous example, what I would like everyone to figure out is log of e to the e is equal to 1, right? So that means somehow we have to put in ln of e is equal to 1. So we are going to prove that. That means e to the exponent 1 is equal to e. So I would like everyone to try this. Okay, so you press this key, press that key, you will see ln appear on your calculator. Then what you do next is you want to put in the e, right? So you want to have the actual e on your calculator. Then I would like everyone to press the shift key right here. Okay, so press the shift key. You will see that there's a little S appear on the corner of your screen on your calculator, and I would like you to press this key again. Press this key one more time. Then you see the letter E appear right next to it. But this is a very important step. Okay, don't forget the key when you press shift. Above that is the e to the x. So this calculator wants you to make sure that you always have to involve the exponent x in this case. So in this case, what do you have for the exponent for e? Which is 1. So I need you to press this key 1 beside it right away. Okay, so don't try exponent, but just press the number 1. Okay, so in this case, you are indicating that find natural logarithm of e for me. Okay, so you tell the calculator find natural logarithm of e for me. So the calculator will give you the answer as 1. So press this equal sign is equal to 1. Okay, so if you try like if you put just ln natural logarithm of e and you don't put this 1 beside it, it will be an error. Okay, so try that on your calculator. Okay, so press the ln. Okay, clear that, press ln. Let me clear this for everyone. Okay, then I will prove that if you don't do that, it will give you an error. Okay, so let's say you put in ln. Okay, ln. So this is hard to see, so let's do the arrow within this color. So it's ln, and then you press shift key, and then you press the key again to get the e, and let's try the equal sign. Okay, so I press shift on my calculator, I put in the e, and I put equal sign, and immediately do you see that it's giving you the thing called syntax error. Okay, so if you do that, it will give you uh, syntax error. Okay. Okay, so don't forget, if you just put ln and then e, then it will give you the syntax error here. Because this e, as the function for this calculator, you must always indicate to this calculator what is the exponent of e. This case exponent of e will be equal to 1, therefore you have to put a 1 beside that, then you don't have that error appears on your calculator. Alright, so let's start with the next example where I actually ask everyone to check this. Log of the base e squared is equal to 2. So why do I say it like this? Or I write it like this? Because notice that the base for this power is the same for the base of this log. So basically, if you have the base for the log is the same as the base for your power as the argument, then the formulas for that is you can just cancel this out. Your answer would be equal to 2, right? Okay, so if I use the definition n equal to base raised to exponent x, that means logarithm of the base b of n will be equal to x. Okay, so then what I can do is I can write it like this. E squared is equal to e squared, which is very true, right? So let's work with this using our calculator. So now you are going to turn your calculator on again, and you press the natural logarithm key right here. Okay, so I press that. I got ln. Okay, now you remember how to put in the e? So that means you put the shift key, and then you press this key again. You will have the e appear beside your natural logarithm, and you have to indicate that it is exponent 2, right? So don't try to put the exponent key at all, but you just simply type in 2 or key in the 2. So I press the 2, I will have that, and I press equal sign, and my answer is 2. Alright, okay, so I hope everyone is clear. It's a bit confusing using the calculator, but if we understand the concept of the natural logarithm and common logarithm, how they relate to the exponential function, then hopefully we can avoid all those errors. Okay, however, remember, it takes practice. Okay, it takes practice for us to master this concept. So anyway, I actually make a note here for everyone. Note that make sure to key in E1, E2, since e to the x already represent the exponent for the calculator Casio FX991MS. Okay, so I also want to introduce some formulas right here. Okay, so ln of 1 is equal to 0. So you can try that on your calculator. Put in natural logarithm of 1. You can have the answer as 0. Uh, and also a natural logarithm of e is equal to 1. And um, also try this using your calculator. Excuse me, you put in e to the exponent negative 0.5, it should give you this value. Okay, so I think I will go over this example right here because sometimes it's easy to make an error raised to a negative exponent. So let's go back to our calculator and I will erase all the thing that we done before. Okay, so I erase all that first. And then I will demonstrate or show everyone how to key in e to the exponent negative 0.5. Okay. You probably figured this out before I try this. Okay, so first of all, can you pay attention to this key? Okay, this key right here. Okay, so this key is the negative sign. Okay, it's totally different from this sign to this key. This one is an operation. Okay, it's an operation. So this one is a negative. Okay, so negative is the characteristic of your number. It's an integer, but this one is an operation. You tell the calculator to subtract. But this key, you tell your calculator that, okay, I'm telling you I'm working with a negative number. All right? Okay. So let's key in e to the exponent negative 0.5. E to the exponent negative 0.5. So first of all, we are going to press the shift key. Okay. I mean the shift key right here. And then we will press this key. So you put shift. Make sure you have that S on your calculator first. And then you press the natural logarithm key. You will have the E appears. And then the next step is to immediately press this negative sign. So it's negative. So it will put the negative right beside this. And you can put in 0.5, which is simple. And now press the equal sign. So what do we get? We got syntax error. Okay, so let's put in here. I got syntax error. So I do this on purpose because I would like everyone to pay attention to something else on here. Okay, so e to the exponent negative 0.5. Syntax error. E, so shift E to the negative 0.5. Alright, okay. So, since that error appears when you actually put this operation key beside it, but if you put in the negative as the negative sign, then you won't have a syntax error. Okay, so keep that in mind. Then your answer will be exactly equal to the one that I indicate on the example. Okay, so do that again, alright? Okay, so before I actually press this key as an operation, will give me a syntax error. Now I'm going to press this key negative sign to have this, and I press an equal sign, and I actually have the answer as 0.606530659. Alright, so I hope everyone got that. Try this operation negative or subtraction beside the negative 0.5. You will see that you get an error. And then if you try to press this exponent key beside your E and put this beside that, you also have an error. Okay, don't forget this calculator built-in. As soon as you put in the E, it's already read that I already indicated at the exponents. You don't need the exponent key at all. And don't forget, it's a negative, so you put in negative. then you won't have any syntax error. Okay, so let's get back to our slide. Okay, I think I'm 30 minutes